Hi, Assalamualaikum to our beloved lecturer and also my friend. So today we are presenting our case study on retaining structure for subject BQS552 Construction Technology. Before we start our presentation, let me introduce our group member. Basically, retaining structures are commonly used in construction to support soil and maintaining stability where there are different ground levels. They are really important in slope areas, road construction, and also development projects where soil stability is critical. For this case study, we select two projects located in Selangor. One is the reinforced soil retaining wall at Setia Alam, and the other one is slope stabilisation using the green Terramesh system at Semenyih. Both projects are based on reinforced soil system, but they are applied in different site conditions and for different purpose.
Now, I will talk about an overview of the selected project, of the two selected projects of this case study. For the first one is the reinforced soil retaining wall at Setia Alam, Selangor. This project was carried out to support a residential development located at a sloping ground. The project used a mechanical stabilized earth, or known as MSE, retaining wall system, which consists of compacted soil reinforced with geogrids. These reinforcement layers increase the densible strength of the soil, allowing the soil and reinforcement to work together as one stable structure. Compared to the conventional concrete retaining wall, this system is more economical, require less concrete, and can be constructed more quickly. For the second project of our case study is the slope stabilization using the green Terramesh system at Semenyih, Selangor. Unlike the first project, this project focused on stabilizing on existing natural slope that had experienced erosion and instability. The green Terramesh system combines steel wire mesh, reinforced soil, and vegetation to strengthen the slope while protect it against erosion. Vegetation is allowed to grow on the surface, making the retaining system both environmentally friendly and visually attractive. Although both projects use reinforced soil technology, they have different objectives. The Setia Alam project is mainly designed to provide structural support for the new development, while the Semenyih project focused on stabilizing a natural slope and reducing environmental impact. Next, I will explain the construction method used in both projects. For the Setia Alam reinforced soil retaining wall, construction begins with site preparation and surveying to establish the wall alignment and drainage layout. After that, the foundation is excavated and a leveling pad is constructed to provide a stable base for the retaining wall. The facing panel are then installed together with horizontal geogrid reinforcement layer. Selected backfill soil is placed in thin layers and compacted each layer to achieve the required density. This process is repeated until the wall reaches to its designated height. Finally, the drainage system, such as perforated pipes and filtered minerals, are installed to prevent water pressure from building up behind the wall, followed by quality control testing to ensure proper compaction and reinforcement placement. For the green Terramesh system at Semenyih, the construction process starts with surveying the slope, clearing loose material, and preparing bench for installation. Green Terramesh facing panels are then anchored securely onto the slope. Next, geogrid reinforcement is installed where required, and suitable soil is placed and compacted behind the mesh. One unique feature of this system is that topsoil and vegetation are incorporated into the wire mesh facing, allowing plants to grow naturally over time. Finally, drainage system and temporary erosion control measures are installed to protect the slope until the vegetation is fully established. In summary, both projects follows similar principle of soil reinforcement and drainage control. However, the Setia Alam project emphasized structural support through an engineered retaining wall, whereas the Semenyih project focused on long-term slope stabilization by combining engineering techniques with vegetation for sustainable environmental protection.
Presented based on two case studies in Malaysia. Retaining structure play an important role in supporting soil and preventing slope failure. However, several challenges may arise during construction due to soil condition, drainage issue, and construction activities. Therefore, proper planning, quality controls, and maintenance are important to ensure the retaining structure remains stable and perform effectively over the long term. Let's begin with Project 1, which is the reinforced soil retaining wall at Setia Alam, Selangor. One of the main problems encountered in this project is poor drainage management. When water accumulates behind the retaining wall, it increases the lateral earth pressure acting on the wall. At the same time, excessive moisture reduces the strength of the soil, making the retaining structure more vulnerable to movement, deformation, or even failure if left untreated. To solve this issue, an effective drainage system must be installed behind the retaining wall. This includes the use of drainage layer, perforated drainage pipe, and filter materials that allow water to flow away efficiently. By controlling the water pressure behind the wall, the drainage system helps maintain soil stability, reduce the risk of structural damage, and improve the long-term performance of the retaining wall. Another challenge in this project is uneven soil compaction during construction. Proper compaction is essential because reinforced soil relies on well-compacted backfill to achieve its required strength. If the soil is not compacted evenly, it may settle over time, causing uneven ground movement and affecting the overall stability of the retaining structure. To overcome this problem, regular compaction testing should be carried out throughout the construction process. Site engineer and supervisor must ensure that every soil layer achieves the required density before the next layer is placed. Continuous supervision and strict quality control help minimize settlement and ensure the retaining wall performs safely throughout its design life. So now, let's move on to Project 2, which is the slope stabilization using the green Terramesh system at Semenyih, Selangor. One of the major challenges in this project is vegetation establishment. The green Terramesh system depends on vegetation not only for aesthetic purpose, but also to provide erosion control and improve environmental sustainability. However, if the selected plant fails to grow properly, the system becomes less effective in protecting the slope. To address this issue, suitable plant species that can adapt to the local climate and soil condition should be selected. In addition, regular maintenance, watering, and monitoring during the early growth stage are necessary to ensure healthy vegetation development. Once the vegetation is fully established, the root system helps retain the soil and reduce erosion naturally. Another challenge is surface erosion before the vegetation becomes fully established. During the early stage, the exposed soil remains vulnerable, especially during periods of heavy rainfall. Rainwater can wash away the topsoil before plants have developed enough root strength to protect the slope. This problem can be reduced by implementing temporary erosion control measures such as erosion control mats, geotextile, or mulch to protect the soil surface. At the same time, an efficient drainage system should be provided to safely direct rainwater away from the slope and minimize surface runoff. In conclusion, both case studies demonstrate that retaining structure can face several construction challenges, including drainage problems, inadequate soil compaction, vegetation establishment, and surface erosion. However, this issue can be effectively managed through proper engineering design, careful construction practice, regular quality control, and ongoing maintenance. By applying this solution, the durability, stability, and overall performance of the retaining structure can be significantly improved. Thank you.
Now, I will compare the two retaining structure projects that have been discussed earlier. Although both projects use reinforced cell technology, they were developed for different purposes and therefore use different construction approach, materials, cost, and performance characteristics. The comparison helps us to understand which retaining system is more suitable depending on the project requirements. The first comparison is the design purpose. The Setia Alam project was constructed to support the residential development. Its main objective was to create a strong retaining wall that could maximize land use while providing long-term structural stability. On the other hand, the Semenyih project focused on stabilizing an existing natural slope for erosion problem. Instead of creating a rigid retaining wall, it used the green Terramesh system to reinforce the slope while preserving the natural landscape. Although both systems use geo-rigid reinforcement and proper drainage, the Setia Alam project prioritized structural performance, whereas the Semenyih project emphasized the environmental sustainability and erosion control. The second comparison is the construction method. For the Setia Alam project, construction begins with site preparation, followed by foundation work and installation of leveling pad. Geo-rigid reinforcement is then placed between compacted layer of the engineered backfill before the wall facing is installed. Meanwhile, the Semenyih project starts by preparing the existing slope through the benching and anchoring. The mesh panel are installed, followed by the following backfilling, compaction, drainage installation, and finally vegetation planting. Overall, the Setia Alam method focused on creating a structurally engineered retaining wall, while the Semenyih method combined engineering with ecological restoration. When comparing cost and effectiveness, the Setia Alam project is generally more economical. This is because it uses locally available backfill materials, has a repetitive construction process, and require less maintenance after completion. The green Terramesh system in Semenyih involve additional costs for steel mesh, vegetation, hydro seeding, and slope protection works. It also requires ongoing maintenance to ensure healthy plant growth. However, despite the higher cost, the green Terramesh system provides significant environmental benefits, including erosion control, natural appearance, and better integration with the surrounding environment. Therefore, each system offers different advantages depending on the project objective. In conclusion, both retaining systems successfully improve slope stability and reduce the risk of soil failure. The reinforced soil retaining wall at Setia Alam is the better choice for urban development, where structural strength, efficient land use, and construction speed are the main priorities. Meanwhile, the green Terramesh system is more suitable for natural slope, where environmental conservation, erosion control, and landscape integration are the important consideration. There is no single system that is better than the other. Instead, the most suitable retaining structure depends on factors such as site condition, project objective, environmental requirement, and available budget. With that, I will now hand over to Syuhada to the conclusion.
So overall, we can conclude that retaining structure play a very important role in construction, especially when it comes to stabilizing soil and preventing slope failure. From our case studies, both projects use reinforced soil concept, but in different way. The Setia Alam project focus more on structural support using a retaining wall system, while the Semenyih project focus more on slope stabilizing and environmental protection. Even though the systems are different, the main objective is still the same, which is to improve soil stability and ensure long-term safety. So basically, the selection of retaining system depends on site condition, design requirement, and also environment factor. That's all from us. Thank you.